Then good morning, everyone, and welcome to the Wasteless workshop of today. This is the fourth workshop in the training series organized by the Wasteless project to showcase the tools that have been developed within the project to track, monitor, and measure food losses and waste along the food supply chain. My name is Luminița Ciolacu from ISEKI-Food Association, and today I'm your host together with my colleague Luis Mayor. We have prepared for you a very interesting workshop with a lot of activities, so please try to engage with us today. The workshop is dedicated to the computer vision-based image analysis tool, which has been developed by the HACETTEPPE University partner in the Wasteless project. The agenda of today includes a short introduction on the Wasteless project. I will share with you the introductory video of the project. And then we have the first activity, which is a Slido. Yeah, you need to answer some questions. So please prepare your phone in order to be able to engage within our activities. Then I will give the floor to the tool developer, who will give us some insights in the tools and present in more details the feature of the tools and also share some results. And then at 10:35, we will open the floor for Q&A. It's your time to ask your question, to make your comment, or engage with us in discussion. We have also a practical activity which relates with the first slide. So please, again, I will say, try to engage with us. And at the end, we will ask you some question about your feedback related to the usability and scalability of the tool, and of course, about the quality of the workshop of today. We will wrap up around 11:30, so please stay with us and enjoy the workshop we have prepared for you today. Before we start, just some general house rules. Please turn off your microphone and camera during the presentation. If you want to ask your question, please, you can write it at any time in the chat and I will read it aloud. Or you can raise your hand during the Q&A session or along the workshop and I will invite you to speak. Also, the workshop is a live stream on the Wasteless YouTube channel. And after the workshop, you will receive an email from me with the link if you want to check again the workshop or if you want to share this within your network, which we will really appreciate. And with this, I will stop the sharing the screen and then I will go straight to the introduction of the Wasteless project. And for this, I would like to share, but this time with sound, the project video so that you get a context about the aims and objectives of the workshop of the Wasteless project. So let me see if it's working like this.
About 88 million tons of food are wasted annually in the EU. This has a tremendous negative impact on society, environment, and economy. The Commission is committed to halving per capita food waste at retail and consumer levels by 2030. This raises a new challenge: the need for a harmonized food waste measuring and monitoring approach. Robust and comparable data of food loss and waste between EU countries should be generated along the food supply chain. Wasteless is a European-funded project with the ambition of reducing food loss and waste by at least 20% annually, gathering together the expertise of 29 organizations from 14 countries. Wasteless will start by developing a mix of tools and methodologies for food loss and waste measurement and monitoring, which will be tested in 5 case studies: industries, retailers, services, households, and a selected food commodity. The results gathered will be used to recommend a comparable set of methods for food loss and waste quantification. As well, these results will be the basis to develop an essential toolkit to be used by all food value chain stakeholders. Additionally, Wasteless will carry research activities on innovative processes and streams to valorize unavoidable food loss and waste. By providing the proper tools to measure and monitor food loss and waste, Wasteless will contribute to its end to the Food 2030 priorities on climate and environment, circularity and resource efficiency, innovation and empowerment of communities. Wasteless, waste quantification solutions to limit environmental stress.
Okay, sorry, I was muted. Okay, so this is the Wasteless project. In total, 5 tools have been developed within the project, and today we will hear more about the computer image analysis. But before we start, I would like to test a bit your knowledge. We'll start with the first Slido activity. So I will share again my screen, and please grab your phone to answer the questions that we have prepared from you in the Slido. Okay, let me see how this works. Okay, so you can join the Slido by scanning the QR code or by going to slido.com and typing the code 7042850. This will be all the time on the screen. So now the first question. You found this fruit in your fridge, which is an orange or a mandarin. Yeah? So look very carefully to this image and tell us, what are you going to do? Are you going to throw it away? You will cut off and eat only the edible part. You will cut off and you will use the edible part to make jam, cake, or something else, or you will do nothing. We wait a bit. We have 4 answers. Okay. So people will cut off and eat. Okay, and 33% will throw it away. Okay, good. Then we go to the next question. You have this apple this time, yeah? You see this apple in your fridge. And what are you going to do? Oh, sorry. No, wait. I think it's... Okay, let me see. So this is the... Okay, now. You will cut off, okay. Or you throw it away. 25% will throw it away. Good. Then we go to the next picture. We have a pear this time, which doesn't look so bad in my opinion. However, I want to know, what are you going to do? You will cut or eat the edible part, or you will throw it away, but okay. So you will cut it and only 13% will throw it away. Good. Okay, more. Also make a jam. This is good. Or make a pie. Okay, good. And the last picture, it's again an orange, which is a picture from another angle. So in this case, what are you going to do? Okay. So this time it's 50-50. Okay, good. So we have your answers. We will come back to this later on after we will see the presentation of the tool developer, and then we will ask again your opinion on this. Now I will stop sharing my screen and I will give the floor to Burs. Burs, you are here, yeah? Burs Atak-Mogul, assistant professor at HACETTEPPE University, partner in the Wasteless project. So Burs, please.
Yeah. Hello, good morning, everyone. I'm going to share my screen. Um, yeah, I think you can see my screen.
Yes,
Good
yes.
morning. My name is Burçe from Hacettepe University, and today I'm going to tell you about the tool that we have developed, a waste management tool, which is based on image analysis. First of all, I'd like to start what the computer vision is. The computer vision is a field of artificial intelligence which can analyze and interpret images or videos, just like we do with our eyes. For example, when we look at something with our eyes and we process it through our brain. But in the case of computer vision, it sees through the camera and processes with the computer. We try to mimic what we are doing with our eye and brain with a camera and computer. It can detect shapes, textures, colors, and brightness, and it can also detect the movement or changes over time. Actually, if you are maybe you are not aware of that, but the computer vision is in our real life, even in your car, for example, which detects the traffic signs and alerts you that you are over a speed limit, for example. But what we are doing is that we are using this computer vision with the food, and in simple terms, we try to quantify what we see visually through color detection. How can it detect the color changes? When you take a picture, it pixels, and all pixels has three-dimensional color values, and most of the cameras they take the picture in a RGB color space, which is red, green, and blue values. So each pixel has one red value, one green value, and one blue value. And these three coordinates, this 3-point coordinate, is one point in this color space you see here. And the computer vision can just analyze the pixels and tries to measure the color shifts. Sometimes it's even invisible to human eye, and it can track changes over time. For example, browning, ripening, oxidation, or some kind of related to the color changes. It can eventually it can provide you some objective information and also repeatable results instead of relying on subjective visual judgment. For example, it is already embedded in many of the food processing lines. For example, like in potato chips, if it is burnt or something, it's just blown off from the processing line. So it's done by a computer vision system by analyzing the color. So there are many other applications in the food industry actually. And there's also it can also detect the food ripeness. For example, if the tomato goes from the green to the red, or it can also detect the bruising, for example, or for example, when you're baking a cookie at home and you are always visually checking if it is good enough, good brown, it is baked or not, you decide it with your eye. And this can also be done by a computer vision, analyzing the image, and you can detect the browning, for example, during a thermal process, baking or roasting, or in any processes. It can also detect the color changes during storage, for example, like enzymatic browning can happen in some sliced fruits or some other color changes. Any color changes can be detected by this computer vision. What we have done, we actually use this image analysis based on the color analysis. So we use the color information from the image, we take the information and we analyze it to make and useful information in the end. And in this case, we are focusing more on the decay because we are trying to measure the waste at household level in fruits and vegetables. That's why we try to analyze the changes in color, which indicates the decay, and in the fridge with a simple camera. And the tool, the objective of the tool is to develop a computer vision based image technique to measure the fruits and vegetable waste, food loss and waste at household level in the fridge. And this tool is a kind of a proof of concept, which would eventually be implemented to real fridges and real cases in the end. I will talk about it later. And what we've done is we took images from different angles, and then we tried to analyze, we tried to correlate these color changes with these color changes with the actual waste. So what the fruits and vegetables that we use within this tool is like you can see here in the slide. As you see, they all have color changes. They're, of course, one of the worst examples here, the apple, pear, or mandarin, or orange, and also lettuce, ready to eat, pre-washed lettuce bags. You can see there are the color changes. So we use this information by just taking the picture and try to relate it with an actual waste that you cut it off and consume the rest, or whatever, you can just throw it away, as you mentioned during the slide. So I just give you one example about the pear. And what we do is we do a weight-based waste calculation. So for example, we have this pear and its weight is around 200 grams. We weigh it and we take the picture of it just for the next step. After that, we just cut it off. The rotten part, like you would do, for example, then you cut it, if you would do, of course, and then you cut it off, and then we measure the weight of the waste. Then we calculate what is the waste percentage in this pear. And then, for example, in this case, it corresponds to around 1/4 of the pear is just gone bad. So it's just a 26 percent. And then the picture that we have taken, we analyze it with MATLAB, and then let's say the pixel amount, just make it simplify, the pixel amount of this pear is 100, and we detect the decayed area and we just exclude it, or you can just take it. I mean, it depends on your calculation. And now let's say the remaining pear pixel is 60. So 40 pixel is already gone bad. So just an estimation. I mean, it's just a calculation based on the image analysis. And then we calculate the waste percentage in pixel. So it corresponds to 40%. It cannot be one-to-one. So it's not just, we cannot find it 26% also from this image. But what we can do is we can relate these two information to try to find if this relation can give us a good calibration kind of curve, and to try to estimate if we have an unknown fruit or vegetable with a decayed part in image. So here, what we see here is this is the one point that I showed you one slide before, and this is the waste percentage in actual gram to gram, so the actual waste, and there's also another rotten area percent taken from the image. So we repeated it several times, 10, sometimes hundreds of fruits and vegetables. Then we obtain kind of a correlation between this actual waste percentage and the information that we got from the image. So we have a kind of a correlation curve here. This correlation curve could give us an information about an unknown fruit, for example, a pear with a, I don't know, I didn't measure, for example, the actual waste, but then I just take a picture And then I found 65% of rotten area from the pixels, just taking a picture. And this correlation can estimate that there is almost 30% of the pear is gone bad. So it can be considered as waste. So using these relations for each fruits and vegetables, we can quantify the waste percentage as weight. There are some examples of the relations between this area percentage and the actual waste percentage. And as you can see, they all have kind of specific relationships for each decay and for each fruits and vegetables. And they all go kind of a plateau in the end. And this is actually the nature of the food, because as you also answered in the Slido session, at some point, it's inedible, so you cannot just cut it out after a certain point. Even it's the image says it's 70%, but it cannot be eaten anymore. So that's why there's this plateau happens in these relationships. And we tested this relationship. We developed this model and we tested it. We tested with the same fruits and vegetables for each action, and we analyzed it, and then we estimated with our curve the waste percentage, and then we actually measure the waste, and then we see if the predicted waste is the actual waste. And it is a pretty moderate, nice correlation between the predicted waste percentage and actual waste. For example, here you can see for a peach. But at some point, at some fruits and vegetable, in the case of lettuce here, for example, on the right-hand side, after a certain point, after a certain decay, the tool cannot predict accurately, because the food become waste after a certain decay ratio. So you cannot really say, okay, it is you can just analyze it until like 35% of waste. After that, it just cannot really estimate it, because in a bag there are some color changes of the lettuce, but it's inedible. So in the end, it's slimy, very bad smelling bag, so you cannot really cut it off or just separate it from the rest and eat the remaining part. It's not the case in the case of lettuce. So therefore, there are some foods they are limited prediction range. So the tool is based on the color information, as I mentioned, but in that case we were using like segmentation approach to extract the decayed area from the fruit and analyze in pixel. But we applied this, not the exactly same approach, but we applied the color measurement approach to quantify to define the meat quality. So we use the color information for the meat quality to define it, either it's a normal quality or is a low quality. So just before the slaughtering or the after, in the 24 hours, there is a change in the quality change in the beef or meat, and it can be a normal quality beef, but it can also go to low quality beef, which can be, for example, say dark firm dry DFD beef. It is classified as low quality, because it is also obvious from its name is that it's a firm and dry, so it cannot be eaten as it is. It should be processed to a meat product, for example. That's why it's very important that the quality of the beef is determined after slaughter at the slaughterhouse, but it should be also very quick. In the case of in the normal case, it's on the pH. There are many chemical analyses like pH or some other markers, the chemical markers that should be analyzed to classify it as low quality or high quality beef. And in our case, we use this approach to categorize the meat, the beef, either it's a normal and low quality, just checking its color by analyzing the computer vision-based image analysis. So we measure the color at different points surface, and then we try to categorize if the normal beef and the FD beef, the low quality beef, can be determined just with the color detected by from their image information. And we classified successfully the DFD and the low quality and normal beef. And we can now, we have the relation, we use the color information and we separate it into two groups. And what we've done is, for example, we don't know if this beef is normal or low quality, but just taking a picture, analyzing its color, and then we can say that it's DFD, and because it can be classified as DFD, and it is just a matter of a picture and analyzing. So you don't need a many chemical analysis to say that. We applied the same approach to pork. Within this project, we use this tool, but I just gave you some impression about the beef here. But this is the similar case also for the pork. Yeah, it's basically the technique relies on two-dimensional image data, and we try to estimate three-dimensional real-time information. So that could introduce, of course, several challenges because we see through only two dimension. And this tool enables the measurement of loss and waste at household level, but there are also some limitation because there's certain limitation to certain fruits and vegetables if they change the color. If they don't change the color, if they, for example, got rotten from inside out, your eye cannot see it, so the camera cannot see it, and it cannot be processed as an image. I mean, it cannot be an indicator. And we developed this tool as a proof of concept to find the relationship between the color change and the waste. And as I showed you before, each fruit and vegetable requires its own specific correlation because they different kind of decay. They different. The nature of the food is more complex than it's just from its picture. And the method also not applicable if you cannot see it. So if they are stacked or overlapped, for example, if you have a container of the strawberry and then you just look it on the top and you say, okay, it's good. And then you take one and eat it, but you see in the middle, there are some slimy and bad strawberry. If you cannot see it, the camera cannot see it. Again, it could be limitation of this tool. But what could be implemented? Okay, the negative side, but what could be the positive in the end? Because this tool is actually developed for a measurement of the food waste, but it could be a food waste prevention tool in the end, because it can be used, for example, with an integration of the simple camera within a refrigerator. And if you take the periodic image capture without your control, just taking the picture from the fridge and analyze it with the time intervals, and image analysis is used to estimate the percentage of this potential waste. Okay, then we can have a tool that can early alert the consumer, for example, via mobile app or something, and telling the consumer that, okay, this orange is going to be bad soon, so consume it. So even though you don't know it, you are not aware of it, if it is alerted by you, then you have this intention to go and consume it. And of course, it could not be that bad image that I showed you. It could alert you way before then it becomes that bad. I'd like to thank you for your attention, and also I'd like to my colleagues from this project that we did all the work together. And I think now we have a Q&A session.
Yes, thank you
Yes.
very much, Pers, for this nice presentation. Now it's time for Q&A, so you can either ask your question in the chat, or I think it's better if you can raise your hand, and I will invite you to speak, because we are not so many people today, so it's easy for you to speak if you have any doubts or if you want to comment something with Purs. Yeah, and okay, Luis, please. You can, okay, then.
Yes, I have a question. Does the measurement depends on the position of the camera? I mean, I've seen that you take a photo from a part of the food, but the other part of the food is hidden. Have you overcome this problem somehow, or how do you approach to this?
Okay, yes, that's why we used multiple. I mean, the intention of the tool is implementing different angle cameras. So it's not just one side, but there are different sides of the fridge. It's not the one in the, for example, in the door of the fridge, but there could be some from the bottom because, for example, a fruit is on the shelf and it can be rotten from from the side that it is on the shelf. So it cannot be seen from one angle. That's why we developed the tool taking from different angles, taking images from different angles and try to correlate which angle is the best to estimate it. So it's not the like you look it and you see one part is perfectly safe but perfectly fine, but the other part, the other side is bad. So that's to overcome this, there should be more than one camera to see from different angles. Of course, I'm not saying hundreds of cameras, but this is also from different parts of the fridge.
Yeah, I was thinking perhaps it's also possible to extrapolate if you have an apple or a pear and it's a geometrical, more widely well-defined figure, okay?
Mhm.
If you only see part of the growing of the microorganisms, and if you consider this growing is radial, for example,
Okay,
you
yeah.
can see, or say, I mean, I see here half of the radial of the circle that is contaminated. I can
Mhm.
extrapolate and imagine that there's another half in the other part, and perhaps
Yeah.
this would improve the correlations.
Yeah. The thing is, the geometry of the rotting, the going bad, going decaying, is included in this model. Because when you, for example, use the apple, you see only very small part of the bruised part or very rotten part, very small part, but actually it goes to the radial, as you mentioned, it's go to the center. But while we are doing the image analysis, we see only the small part of the color change. But when we are using the actual while we are developing the tool, we cut it off and we use the actual waste. So we are actually cutting off the radial part as well. So it's not only the surface. So we cut the real part, the real decayed part. So when we relate or correlate, let's say, the small image and the information from the image with the small area, but the bigger part, the higher waste from the actual waste, we include the geometry of the decay into the model. So that's why I told you, in the end, each fruits and vegetables needs its own specific decay graph, the correlation, because each one includes its own geometry of decay by the nature of the food. So
Okay, thank you.
thank you.
Yeah, I would also like to, sorry, to make a comment related to this, Purs, because when you wait to do the correlation, Because sometimes it's not also only a change in the color, it's also a change in the texture. Like the apple becomes softer and you see it's not. Do you consider all this or only the part which has a change in the color?
While we are cutting off the fruit, again, it's very similar to the question of the Lewis. It's a very both were very good questions, and normally we, as you said, there's also texture changes. But when we are cutting off, we also consider all the bad parts from that area causes in the fruit. So the area is very small, but the decay, it is caused in the apple, we cut everything out. So in the end, we consider also the textural, or like you cannot all the part that you cannot eat, basically. So that's why when you weigh, you find 26%, but from the color, from the image analysis, it's 40%. So it could be vice versa. So the relation is in itself. So that's why the numbers are not actually the similar, but the relation to estimate the actual waste from either it's a very higher area or either from it's a very lower area, because it includes the information from actual waste.
Yeah, and this is why you need to train the model.
Yes, that's why we use maybe hundreds of fruits and vegetables to build the models, just to make sure that it works.
Okay, we have a question from Lisa. Lisa, you can turn on your microphone and camera.
I'm not able to switch on my camera, I think,
It's
because
fine. We hear you very
turned
well.
it off earlier. Yeah, I was wondering if it is possible for the system to distinguish between mold and actual spoilage, because the picture of the pear earlier, I think it was...
I'm sorry, Lisa, there was a misconnection. Could you please start again? I'm sorry.
Yeah, of course.
Okay.
I was wondering if it is possible for the system to distinguish between mold and actual spoilage, because I think the pear you showed earlier was very moldy, and I wouldn't eat that. I mean, I wouldn't cut it away and eat the rest of the pear, because the mold is the other half as well. So I was wondering what you do about this.
Yeah, we did not consider the safety part, but the thing is, I showed you the worst cases just to make the impression. So we, of course, in that case, it seems like very bad, but we didn't measure as like a mold or the I don't know. We didn't measure the microbiological count or something. So in the end, yes, this is what you decide. But in the end, it can be cut it off and then eaten. The rest of the part could be, in some cases, maybe not all cases, of course. I just make the impression that there are very bad cases happens. But of course, the idea is not to make that fruit or vegetable to that level. So we have to stop at some point before that.
Absolutely.
And to use it to decrease to measure, and in the end the decrease the food waste.
Okay, thank you.
Thank you.
Thank you very much. Are there any other questions from the audience? And I was also curious, Purs, because you said that this is, and I know this is for households, but is this not possible to be used in the industry? Because I imagine, in the industry, they have these trails, and then fruits are going from one section to the other, and then you can have the cameras which can spot this very easily. So I think, from my opinion, it can be useful, but maybe it already exists. I don't know. I know the focus is households, but it was just in my mind when you said that it's for household. It can be also used in the industry, no? I think we have lost Purs, or it's just me.
I think
Who
we
is
lost her.
Is me frozen or is she?
No, it's
She
her.
frozen, I guess.
Yeah,
Okay.
I can answer the question because
Okay.
our Wi-Fi is not so good today.
Okay, please.
Like actually, I don't know if the industry actually uses this kind of tools for the waste management, but we know that the industry uses color image analysis to decide, as Burç already mentioned, for baking or for other quality changes. But I don't know if the industry uses wasted pears or other fruits. But I know that the industry uses the unrotten part of the apples to make apple juice because of its microbiological nature, the toxins cannot move towards the unrotten parts, so they can process the unrotten parts of the apples for apple juice. But I don't know other examples. Burçe, do you know any other fruit examples that the industry uses?
No, I don't know any other, but the thing is why we focused on food waste measurement at household is that the biggest food waste at home is fruits and vegetables. I mean, it's also in my house. I try to be more effective with this project, but it doesn't really help if it comes to, the fridges in the end. So the biggest food waste at home is fruits and vegetables. That's why we focused on household. But of course, it can be implemented with higher amount of fruits and vegetables if it can be. I mean, it would be also easier because they're on the trays as a line of fruits, and it can be processed from their image if they're bad or not. But now I cannot think of any industry any application in the fruit industry that uses this kind of application.
Yeah,
I
this is
can
true
give
because
an-
yeah, please, Lisa.
I can give an example maybe. I don't know if it's exactly the same system, but I know in the production of packaged salads, there's when they wash it afterwards, the salad is spread out it's spread out, and with color detection, they detect brown leaves to get them out of the green ones.
Okay, so it's already implemented. Okay. Yeah, because the big problem in the food sector is the households. They are producing the most waste, and the most wasted food commodities, fruits and vegetables. So this is why you focused on this one. Yeah. Luis, last question.
Yes. What after that, when the device identifies the starting to rot fruit, what happens? Is there any alert for the consumer, for the family?
Not yet, not within this project, because within this project, we would like to show if we can really measure this color change with the food waste. And now we applied to some fruits and vegetables, and we showed that it can be. But afterwards, it can be later as an implementation to the fridge and using by an app or something, it can alert the consumer to use this, but before going that bad, not just because the color change can be, even small color changes can be detected by computer vision. So sometimes even you cannot really see or focus, but it can detect the changes. So in the end, it can alert the consumer, okay, it will go bad, I don't know, like in 2 days. So
Yeah.
This is your last chance. Either you use it or you just leave it.
I suppose that an alert can be when 5% is identified bad, because if it's 25, perhaps has to go to the bin, no? So some kind of criteria must be applied there as well.
Yeah, that's true.
I see the point.
Yeah, but there are also already some fridges, commercial fridges that includes the camera, but they are not using this approach. They only they are connected to the mobile app, for example, and you are, for example, in the grocery store, and then you open the app and you look at the camera, and then you see inside of your fridge, and okay, I ran out of milk, or I ran out of eggs, so I will buy it while you are in the grocery store. So why not application of this tool, for example, this kind of fridge, just taking the pictures more periodically, not I asked, but it should take the periodically to analyze the changes over the course of time. So that could be implemented later. Now it's a kind of waste measurement tool, but could be waste prevention tool in the end for a consumer.
Yeah, I think this
Okay.
is very nice, and it can be combined with other apps, as you said. And it's somehow making us to plan better, which will in the end be a prevention measure, not to waste so much. But then we need also the opinion of the developers of this kind of fridges and so on, so they could tell us better
Of course.
if
Of course.
the investment will make sense. Okay, good. So this
Yeah.
was
So
very nice,
in
and the
the end,
discussion.
the final aim is to do a shopping list made by AI or other tool, not manually. No?
Yeah, because this will consider also the prevention.
Yeah.
So it will be efficient. Okay, so now after all this interesting presentation and talk, we come back to the Slido. So please take your phone, stay within this Slido that we have started, because we will ask you again if you are going to eat the fruits. So I'm here where we left the other time, yeah? So let me see if I can move.
Can you put it again? Sorry, just a moment. Yeah.
Yeah, you see now?
The Slido, sorry, the QR code.
The QR code, I think it
Yeah,
was this
before.
one.
Yeah.
Yeah, this one. I give you some
Okay,
minutes
thank you. Yeah, please.
to scan the QR code, and then we go again. So you have seen this picture, and you said that, so 67% said that they will cut off and eat the rest, 33 that they will throw it away. So what do you think now? How much of this orange do you think it's wasted? Okay, so between 0 and 25% we have here. We wait, we have four answers. Maybe we get some more. I think we had 8 in the other one. So I will throw it away, 70%. Okay, is someone still answering? Okay, no? Okay, so let's
In
go.
the other, we had 67, 33.
Yeah,
Luminita.
67 with 33.
And 0,
So
0.
now, Burs, if you want to explain a bit.
Yeah, this is actually one of the good examples that the tool can predict the waste, because the predicted waste from this image and from the calibration curve that we built, the model that we built, it can be predicted as 12%, and the actual waste is 14%. And you were right. I mean, the results were within the 25%, and what you see and what the camera sees actually is the correct. So it is corresponding to a lower actual waste. And there's also decrease in the I throw it away percent. I also like this.
So this is a good correlation to understand, no, between the
Yeah.
predicted waste and the actual waste. Good.
And also the human eye also says it's less than 25%. So this is a very good correlation.
Okay, and now we have a picture from another angle. So what do you think now? How much of this orange was wasted? Okay, so more. Now I will say no, 26 to 50.
Yeah.
Before 75, 25.
Yes, so let's see what the model says.
It's actually the same image that we showed you before, one slide before. So this is the angle matters. So, and our model includes the angle. So that's why it's important that different angles would give the same results. So in our case, the predicted and actual waste is the same with the same orange the slide before. So, but when you look at from this angle, you think it's more than 25% is bad. But no, it's the same.
So in this case, some of us have been tricked by the our eyes are not so good as the model. Okay, let's go to this apple. Yeah, so look again at this apple and tell us how much do you think it is wasted?
And Luis, you see you see also the radiant the geometry of the decay in the apple. It's very obvious.
Yeah,
It
yeah.
starts very small with that radial angle, but then if it gets back, it's more obvious. Yeah.
Okay, so we have also someone saying more than 50%. We have 6 answers. So 83% says that 2650. Let us see now what the model says.
Yeah, the predicted waste is 11% when you look at the image, but the actual waste is higher because now the area is not very well correlated with the actual waste. Due to this, also the geometry as well. And the textural change you mentioned before. This like, I mean, sorry, Dominika. And the text, because we cut it off sometimes more than it is obvious because it cannot be edible anymore. So sometimes there are some deviation from predicted waste and actual waste. And I think human eye were better in this image. It is closer, I mean, it's 50% less. I don't remember the results from this.
83 said it's between 25 and 50, and only
Yeah,
one
okay.
person
So
said.
yeah, the human eye is a better guesser now in this case.
But in this case, it's the same. No, the angle matters because if you see from above, it's maybe
Yeah.
different as you see
Yeah.
from the side. Okay,
Yeah,
good.
true.
Now we go back to the peer, which, yeah, doesn't seem so bad, but tell us how much do you think it is wasted? Okay, so we have 50-50 here. 0-15 and 16-30. Let's say what the model says.
Yeah,
23.
again with the the actual waste is on the tree. It's just a very small part of it. It's just it's damaged probably, and it started going bad. But a very small area, so the predicted waste is 5%, but the actual waste is 3%. So it's very good estimation. And it is also important after, as I showed you before, after certain decay, the model cannot really predict it because it becomes inedible in the end. So there would be no correlation later stages of the decay. But here is a very good example. With the start of the waste, you can say that the model the model estimates good.
Yeah, and in this case, it's not molded, it's just damaged. So it's good because it detects any kind of change in the color, as you said in the beginning, also browning and these other
But there's
types
also
of color
started some,
change.
but you can also see some kind of halo, I don't know, around it. So it started already. So it's a very early alert. So it could be, if we stored it, I don't know, 5 days, and it would go faster bad than the other healthy pairs, let's say. So,
Okay, good.
yeah.
Okay, so now we see the other orange, or maybe this is a mandarin. How much of this do you think it is wasted? Okay, so we have also someone saying 51-75, 40-40. Okay, 7, maybe one more answer or not? Okay, let's see what the model says. So we have 50% between 26 and 50. And yeah,
Yeah.
I will throw it away. This is also an option.
Okay.
Okay,
Yeah.
so let's see what the model says.
Yeah, because there are some nature of the fruits. In this case, for example, it has the peel. And also there are some color changes maybe you will see when you look carefully. There's this translucent part, not the color changed moldy part, but there's some kind of translucent part that has already gone bad. So yeah, I mean, in the predicted waste, from this angle, let's say, the model predicted as like 70% of waste, but the actual waste is actually not that bad, but also includes the peel. That's why also kind of be careful about this waste percentages, because it also includes the peel. We calculated with peel or also without the peel, but there is not big much of a difference. The indicator is on the peel, and sometimes it's not that bad inside. That's also a kind of a tricky one.
Yeah, and I think now you also mentioned something which is also important in these kinds of fruits, because the peel is going to waste. So somehow it's already calculated as a waste, but you need to consider only the inner part, which is the actual waste, and not the peel itself, which even if it's damaged or molded or not, it goes to the waste.
Yes.
Okay,
exactly.
good. Yeah, thank you very much, Purs. And now we go to the first questions. Yeah, you found this in your fridge. What are you going to do? So, did you change your mind, or you stay with, I will throw it away, I will cut off and eat the edible part? We had 50-50 in the beginning. Now we go, okay. We have someone in. Okay, so I will cut off and eat the edible part with 67%. So maybe we save some waste. Good. What we do in case of the apple? You will cut off and eat, or do you throw it away? Or maybe you'll use it to make jam cake, or now it's good in autumn time to do an apple cake. No? Okay, so we stay with 58%. In the beginning, we had like 75% saying that they will cut off and eat, and now only 58%, so more people will throw it away. Okay, good. Then we go to the pear. In this case, what are you going to do? Okay, someone will also cook. We'll make jam, and 75. I think this is similar with what we had before, because we had the same 75% will cut off and eat.
75, 13, 13.
Yeah, and I will throw it away.
Very similar.
This is very similar to the first. So in the case of the pear, we see no changes. And then let's see the mandarin. In the mandarin, we had 50-50. So what do you say now? Okay, so more to eat the edible part and only to 33% to throw it away. Good. This was really interesting to see that after listening the presentation of Purs, we can somehow see that our eyes are good to estimate the waste, or not so good in some cases, depending on the angle. Are there any other comments or questions or remarks that you want to do at this point? No? Everybody happy? Then now it's time to continue the Slido, but with some questions related to the usability and applicability of the tool and the quality of this workshop. So I will try to move. Okay. So the first question, how do you see the usability of this tool? Is it difficult to use even with training? Is it difficult and prior training is needed? Is easy after prior training, or it's easy to use? So how do you see this tool? Do you understand how it works? Do you think you need more training on the use of the tool? Okay, we have 8 people. I think no one is answering. Let me check. Yes, we go to the next one. Okay, how do you rate the innovation level of this tool? And here you can say 1, similar to existing conventional tools, or 5, goes beyond the state of the art. No, we have equal scores. Let's see if 2 more answers. Okay, we have the 8 answers. I think we are fine. We go further. How will you rate the scalability of this tool within its target sector? So for the households, 1, not scalable, or 5, easy scalable? Okay, we have the 8 answers. What improvements or adaptations will you suggest for this tool? And here you have time to write, so I will leave this question a little bit more so that you have time to write your adaptations or improvements. This is quite useful for the tool developer and also for us, for the project itself. So please think 1 minute and write your answer. Or you can also write no adaptation, no improvements. Okay, so we have the 5 answers, but okay, and 2 participants are typing. I will wait because we are good with the time. Good. Now I think everybody answered. So I think this was the last question related to the tool. No. Okay, we still have one. How can your research benefit from this tool? Just a reminder that these workshops are aimed mainly at food losses and waste researchers, and that's why you see the word there, research, but you can specifically mention your work if you are not a researcher by definition, but you can still tell us how do you think that your work will benefit from this tool. Okay, so I see no one typing. We have 4 answers. Okay, one more. Good. So yes, let's go further. Now we go to the questions related to the workshop itself. Did you find this workshop useful? So it's again from 1 to 5. I think here it's faster, so I wait the 8 participants to answer. 5 only. We lost some. 6. 7. One more, or I move. Okay, we go to the next one. What was the part you liked the most? The tool presentation, the results, or the activity? Okay, we have the 7 answers. Good. What would you improve in the workshop? This is again to write, so I will give you 1 more minute in silence. Okay, we have 5 answers. Thank you for your comments. Yeah, no one is typing anymore. And with this, I would like to thank you for your participation, to the presenter of today, Burs, and to my colleagues. And with this, I will stop sharing. And we still have some time. If someone wants to make any comments or to talk about anything else related to this tool, I will just want to say that we have still 1 workshop remaining, dedicated also to the households, which will be next week on the 10th of November. So I will, you will find the invitation to register for this, and I will send you also by email later today all these details, so you can join us also for the last workshop. And if everybody is happy, then I will say thank you very much for joining, for participating in the